In this video, we'll explore media types. What are they, and how can they support digital preservation? Let's start with some learning outcomes. By the end of this video, viewers should understand what a media type is and how it works, know some common media types, and understand how media types relate to digital preservation. First up, what are media or MIME types? Well, you can forget about the beret and striped shirt. MIME stands for Multi-Purpose Internet Mail Extension. They're now more commonly referred to as media types, so we'll call them that too. MIME itself is a standard that indicates the nature, format, and type of information contained within a digital object, which enables servers and clients to exchange and represent the object on the internet. If the MIME acronym sounds outdated now, that's because MIME was originally a technical specification developed by the Internet Engineering Task Force to extend the body of email messages so that they could support new content types and formats, including non-textual attachments like audio files or images, and text encoded in character sets other than ASCII, which is the most commonly used for representing text. MIME was published as a specification back in 1994 in Request for Comments 2045. Media types were defined in 1996. Today, MIME has expanded far beyond email. It's now used in internet protocols such as HTTP, as well as HTML, the standard markup language for creating web pages. The official registry of media types is maintained by the Internet Assigned Numbers Authority. New media types are registered all the time, and there are currently thousands. So let's take a look at how media types work. A client sends a request to a central server to ask how to interpret a digital object on the internet. The server examines the object and its associated metadata, and based on that, it sends a response containing instructions or code for how to interpret that data. This response includes what's known as a content type header, which supplies the media type. This tells the client what application it needs to launch to represent the digital object. It's useful to imagine this exchange as a conversation. The client asks, "How do I represent this object? What is it?" The server identifies the format and content and responds with the media type. This is application/PDF. From this response, the client knows which application to launch in order to represent the object for the user. In this example, it's a PDF reader. There's just one more thing that we need to know. Media types comprise two parts: type, which describes the registered media type, and subtype, which usually describes the file format. They may also contain a parameter value, which describes the character set or other encoding information. It's hard to visualize this without an example, so let's look at one. A common example is image/JPEG. This tells the client that it needs to launch a JPEG viewer to see a JPEG image. And, as most browsers have inbuilt JPEG viewers, which are always running, this task is a straightforward one. The IANA recognizes 10 registered types: application, audio, example, font, image, message, model, multipart, text, and video. Each of these types has its own set of possible subtypes. So how does all this relate to digital preservation? Well, media types are part of a digital object's metadata, which, as the Digital Preservation Coalition reminds us, is essential for managing and preserving digital materials over time. We need to include media types in preservation metadata because they provide technical insight into how a digital object has been identified and represented over the passage of time. We can find out our digital records media types by using file profiling tools like Jove, which analyzes digital objects and provides us with their essential representation info. At the bottom of this example, you can see that the media type of this JPEG image is unsurprisingly image/JPEG. Of course, media types have their limitations. Although they contain key data about file formats, they shouldn't be used as sole unique identifiers for objects. That's because they don't provide enough granularity about specific objects and their specific formats. For instance, PDF-A and PDF versions 1 through 1.4 all had the same media type, application/PDF. To tackle this, the National Archives uses its own persistent unique identifiers for each and every file format registered on Pronom, its file format registry. We should also keep in mind that file formats are constantly changing, growing obsolete, or being replaced, which makes it harder to access digital objects as they age. The lack of granularity provided in media types means we can't rely on them as unique identifiers for obscure or obsolete file formats. So, we have to keep an eye on changing technology and always bear file formats in mind when we ingest born digital material. When it comes to media types, here's what you need to remember. Media types indicate the nature, format, and type of information in a digital object. This, in turn, enables servers and clients to correctly represent the object on the internet. Media types always comprise a type and a subtype, and although media types alone can't serve as identifiers for digital objects in your repository, they should still be included as metadata because of the essential technical context that they provide. Thanks for watching. If you'd like to learn more about media types, check out the links below.